All right, this is Braedon, Williams, and Dylan Bartell for assignment 1 in 330. This is our multi-threading assignment. VS Code. Start up at the top. Here we're just importing threading for the threading class and importing time so we can track output, which you'll see later. Importing colorama, which is going to help a lot with our output, and then importing random. That's just so that we can generate random numbers for the accounts and the actual balances. Starting out, making the bank account class. This is the constructor for it. Just creating an initial balance here, and then the lock, which will come into play later. And also each bank account is going to have an account number.
So each account is going to be able to perform deposits and withdrawals. For those, we use these thread-safe deposit and withdrawal methods, which are generally pretty similar in function. So at the beginning of that, we're going to make sure we're taking the absolute value of the amount we want to process, just so we're not using a negative amount. We're going to set up a timer, and we're going to use this so that if when we try to deposit, if the parent account is locked, then we're going to start counting how much time is going to pass. We're going to say that it's already locked, and then we're going to wait until the lock is available. And then if it had been locked, if the timer is actually counting, then we're going to say how long we had to wait for that lock to become available. And we're going to say we're entering the area to perform the process. If there was no lock, if it hadn't been locked, then we're just going to say we're directly entering the area. And these are color-coded using that colorama library that we imported. So we're going to perform our process, which here is adding the balance, or here is subtracting the amount, which if we're trying to withdraw more money than we have in the account, we're going to print that in red and say that we couldn't do it. So once we're done with that process, we're going to say we're leaving the critical area, and then we're going to release the account's lock.
All right, so now we have the deposit thread, the constructor for it. Basically for each account, it's just having it so each account is going to have its own thread for the respective actions that are be taking. So depositing here or withdrawing here.
So we use those threads to actually perform the processes of depositing and withdrawing, which we're going to use down here in the main method with each account. So our main method here is we're going to create, in this case, 5 different accounts with random starting balances, and we're going to add them to a list. Then we're going to we're first going to calculate the amount of money that we're going to deposit and withdraw. We're doing that separately before we make the threads, just to make the thread addition faster so that we can have more threads processed more simultaneously, as you'll see in the output. So we actually create those threads for withdrawing and depositing money when, again, those are going to make sure that we're not depositing and withdrawing at the exact same time through the use of critical areas and locks. And then after we've created all those, we're going to check our list of threads which we've added these threads to, and we're going to wait until all of them are dead, and only after that will we say how long the program took to run, just so we can show that the program is fairly efficient and is not taking an extremely long time. So let's show some example output here.
All right, so starting up at the top, you can see account 0 enters the withdrawal area. It says what the current balance is, which was that randomly generated number. It says what the action is, which is withdrawing 838. The program recognizes that it can't do that, says it's too low. Just going to try to find the problem that we talked about in class a little bit with the timing, right here.
So one example of a slight hiccup with how the representation of our program works is you can see here with account 4, we can see that the account 4 withdraw is leaving the critical area and it's saying that the account is unlocked. But then account 4 deposit says that it can't perform its action because because withdraw had been locked, despite withdraw saying that it should be unlocked by now. This is just because by the time that account for withdraw, in this case, processes its action and prints this out and actually unlocks the account, account for deposit has already checked to see if the account is locked, and it took some time to print this deposit message out. So those are just small debug hiccups with the representation of the program, but the underlying functionality you can see here. For example, account 0, withdraw and deposit can't both perform at the same time because of the lock. So account 0 is withdrawing, and account 0 deposit can't enter until after account 0 withdraw is already done.
Yeah, so the bottom here is just saying how long the total program took to run, which is about half a second in this case. When that's again from the original up here saying going through all the threads, making sure that nothing's happening. It prints out the final time it took.
All right, thank you. That was Dylan Bartell and Braedon Williams again, and that was CS 330 assignment 2.